Hi, I'm Tricia, and today Piero and myself will be talking about collecting, designing, and communicating data in the African continent. But more importantly, we will talk about how these processes contribute to governance, accountability, decision making, and empowering citizens in Africa. Code for Africa is Africa's largest civic technology organization. So, what this means is that we use data to create tools that aid in government accountability and informed decision making. Our team is made up of analysts, journalists, technologists, and designers distributed all through Africa and some in Europe. CFA has various initiatives. One of our initiatives is Academy Africa, which is our training initiative offering free training in the form of webinars, in-person training, and MOOC courses. Our MOOC has a few introductory courses on data visualization, and this covers topics such as choosing different chart types or how to use tools such as Flourish or Data Wrapper. So a bit about me. I come from an academic background in earth sciences, and being an unemployed graduate for a few months, the world of open data somehow found me. And since then, the rest of my life became all about data for good and tech for good. I currently manage CFA's data lab and work on long-form data journalism features and data tools. My particular interests are in topics such as climate change, water, gender inequality, health, and other social economic issues. I love data, I love maps, I love viz, I love hackathons. But at the center of it all, I love how data is the key to driving change and impact in Africa. Let's take a deeper look into how CFA goes about creating change and impact. Our storytelling strategy has two objectives. One is to use data and digital content to create interactive visuals to help simplify complex issues. The other is to use data and digital content to create interactive tools for personalized decision making. Data viz is the most common approach used amongst data activists in Africa. While CFA, we do create data viz, we favor the data tool approach to give people actionable, hyper-local, and hyper-personal data. Code for Africa has more than 100 projects in its portfolio. These projects are supported by civic bots and machine learning tools. This example from Tanzania shows our full circle model. We underwrote data-driven journalism about child marriage, pregnancy, and gender-based violence, supported by a Facebook helpline bot that connected audiences with specialized NGOs. This included a grassroots data graffiti campaign that ran alongside the journalism, using data infographics to bring offline audiences to online content. We're quite realistic about the data availability in Africa. These are the land registries in Kenya and Nigeria. Half our job is helping partners find and digitize these kind of deadwood records to give both journalists and citizens accessible and actionable local information.
Hi everyone, my name is Piero and I'm an information design consultant at Code for Africa. In this presentation, I will share with you how we visualize data at Code for Africa to create actionable tools that can empower citizens. And we mainly focus on two types of products there. We either work on data-driven open portals or we work on digital tools that can empower citizens in Africa and counter misinformation. For example, we recently redesigned the National Bureau of Statistics data portal in Nigeria, focusing on clarity and legibility and rethinking entirely the way census data was presented and displayed for the Nigerian audience. We've also created tools for holding public officials accountable, like this promise tracker that we created to monitor, track, and visualize promises made by elected officials in Kenya. Let me give you a little bit of my DataVis background and tell you how I got to work at Code for Africa. I spent years in London-based design studios like Information is Beautiful, Beyond Words, and Signal Noise to create compelling, bold information design projects for corporate clients and brands. It was during those years that I had the opportunity in 2016 to attend a data hackathon called Data for Change. Maybe some of you know about it. And that experience really changed the way I now think about data visualization. In the workshop, I got to work with an NGO from Egypt that needed help to visualize data about protests in the country. Their request was to help them to create a usable tool to display and to explore all the protest data that they collect every year. The example that you see here in this slide, in fact, was one of the early experiments they had made. And they came up with this kind of projects because they weren't happy with what they were able to do. Not because it didn't look any good, but because it wasn't very useful and usable from their audience. So me and my team, we got to work in the few days that we had available during the workshop, and we created a proof of concept for an explorable digital dashboard that would allow users to dice and slice the data about protest, but also to deep dive into the stories behind the data, infusing it with data journalism elements and really going behind the data. This experience was very useful for me because it really made me think about data visualization as something that can be actionable and that can be used by people to extract meaning if you're working on the right type of data sets.
The first case study is a project called Outbreak Africa based on the COVID-19 outbreak. Outbreak is a data and community project aimed at providing tools to combat the COVID-19 infodemic in Africa. These tools will empower citizens, scientists, media, fact-checkers, and national statistical organizations. When COVID-19 hit, African governments didn't know how many hospital beds or ventilators they had available. This became a turning point as officials realized how important data collection and literacy are in decision-making. We began the project at the start of the pandemic, and it was named one of the top 10 COVID-19 data journalism projects in 2020 by datajournalism.com. We then continued our work in 2021. Outbreak has a few components. We first searched for a country's national deployment and vaccination plan. The vaccination plan helped us to identify the vaccination rollout phases. We then went about searching for data sets in each rollout phase. For example, if the Kenyan government decided to vaccinate all teachers, we sourced the number of teachers in the country. We were also sourcing data on a subnational level, so decision makers were able to determine how to geographically distribute vaccine doses if they want to vaccinate a particular group at a particular time, such as all teachers. Vaccination uptake is still low in Africa, so we also wanted to pay attention to vulnerability and calculated the African COVID-19 Vulnerability Index. The datasets used were then made into interactive visualizations. We offered Warner Data fellowships to journalists to report on the vaccination rollout in their country. So Warner Data is a Code for Africa initiative that is a network of female-only data scientists, storytellers, technologists, and designers. PesaCheck, which is another initiative of Code for Africa, published fact checks on COVID-19 claims on anything ranging from fake cures to anti-vax rumors. We selected 2 Wikipedian in Residence fellows who spent their time editing and updating COVID-19 related articles on Wikipedia and uploading verified datasets onto Wikidata. This amplifies our work as the content has the potential to reach millions of Africans. We also have been conducting research to identify medical doctors, scientists, epidemiologists, and academics that are leading the way in research on COVID-19, its impacts, and the vaccination rollout in Africa. These experts will form a Rolodex to show those at the forefront of COVID-19 research in Africa. All of these stories, data, visualizations, and resources are published on the Outbreak Open Data portal. CFA's team of data analysts supported the Wonder Data Fellows with interactive visualizations created on Flourish and Data Wrapper. The visualization on the left was created for a data journalist in Kenya. She conducted an analysis using R to predict the number of vaccinations that will be administered by the Kenyan government by Christmas. Her analysis was within the range of the actual uptake. Some of the challenges we faced with the project, a major one of them was the lack of access to data. It's been even more difficult to find data on a subnational or regional level. We then had to opt to use national level datasets found in open data portals such as the World Bank, as the data wasn't readily available on national government websites. For some countries, we were able to find data in PDF reports, but the scraping and cleaning process has been very tedious. In Kenya, for example, there are 47 counties and each county has its own PDF report. So we had to go in and scrape those 47 reports. We also tried to reach out to various government agencies to partner with us on Outbreak, but we've had very little success with that.
And now let's take a look at the visualization of data in Outbreak Africa. Outbreak Africa is a website that hosts a number of reports, data sets, and data journalism pieces on the outbreak of COVID in 5 African countries. However, the website is not merely just a dashboard of data. It also includes news articles and in-depth analysis from healthcare workers. The brief of this project initially was set out to obtain 3 goals. The first was developing an updated COVID-19 vulnerability index for African countries. This means that the index is determined by combining a number of metrics and data sets that helps identify the areas that are most at risk and are based on those specific parameters. It also aims to publish data research and debunks on large social media platforms like Facebook. And then lastly, it also aims to create a customized frontline data collection tool for real-time field reporting. The type of data sets range from information on vaccination status to more general statistics like population demographics and availability of healthcare workers. This is particularly helpful to identify vulnerable areas within the country's capacity for medical response. Datasets have also been clustered in 5 larger macro categories, such as vaccination, epidemiology, healthcare system, demographics, and water facilities. These categories are also explorable sections of the website. When designing the platform, we focus on 3 design criteria. For example, clarity. Does the choice of parameters and the chart types make the message clear? Was it good to use a tree map instead of a bar chart here? Usability. Can the modules be shared as a standalone data visualization element? And this is particularly important because we want the data viz modules to be shared outside the website as well. And connected to this point, consistency. Can we keep a consistent visual language across this very large variety of charts? Let's have a closer look at some of these charts. We've grouped subjects visually to create a curated experience. The first topic shown is vaccination data, with a focus on ratio of vaccinated people, vaccine types, and vaccine sources. Bar charts were used predominantly to show demographics of the population divided in age groups. The epidemiology section is focused on data about diseases within the country. You can also see a visual theme going on across the topics. For example, we used bubble chart for most of the charts in this section. All of the charts and datasets are explorable with a series of filters at the top of the page, so that the user can scroll through the data to get a bulk of the information or select a pre-configured view. This allows the viewer to customize their experience. The modular nature of the charts also allows flexibility, especially when, as we add more countries to this website, we might incur into some data availability issues. Therefore, the flexibility of the module allows to make for some of the missing data sets that we will need to replace with something else.
The second case study I'll be looking at is the Pesa Yetu tool. Corruption and misuse of funds are common in county-level government in Kenya, and the public isn't always equipped with the knowledge to hold their government accountable. A majority of the public relies on radio stations as the main source of news and information. The tool is part of the Our County, Our Responsibility project that aims to upskill 56 citizen reporters in 14 grassroots radio stations across 8 counties in Kenya to report on budget and development issues in their county, which will now aid in government accountability. The project has the potential of impacting millions of people in Kenya. The project has 3 main components. The first, to train reporters, the second, to support story production, and the third, to create the Pesa Yetu tool. We'll be looking into more detail at the Pesa Yetu tool. Our team of data analysts support the participants with creating social media assets in the form of simple infographics and visualizations using Flourish and Canva. These assets are published on the radio station's Facebook, Twitter, Instagram, and WhatsApp accounts. The reporters also attach a short audio recording alongside the visual on WhatsApp. So how did we go about doing the Pesa Yetu tool? Each Kenya county creates a 5-year development plan called the County Integrated Development Plan, or the CIDP. And this was the basis of our data analysis work for Pesa Yetu. We sourced the CIDP for each of the 8 counties, which were only available in PDFs. We had to scrape hundreds of data sets from each PDF into a spreadsheet, clean them, upload them to the database, and then create the interactive charts. Again, some of the challenges we experienced with Pesa Yetu is the same challenges we experience with many of our projects. We had to scrape hundreds of tables of data from PDF reports. Data was reported differently by each county. One county may have published data on, for example, the number of children enrolled in private schools, and another may have published data on the number of children in high schools. This makes comparing data quite difficult. Again, a county with high tourism will publish data on tourism, and a county focused on agriculture will publish more data on agriculture. Another frustrating challenge was that the budget figures weren't adding up, and also there was no metadata available to verify abbreviations. Granular project and budget data weren't very straightforward to clean and visualize, but Piero will take you through how we went about doing so. Project and government departments had very lengthy names, and for that, we entrusted our in-house copy editing team to polish up our final product.
Let's now take a look at Pesa Yetu from a data visualization standpoint. The platform Pesa Yetu is a website that helps users explore and compare data about the public budget spending in Kenya across counties and municipalities. The platform allows the user to select a county in Kenya and explore dozens of data sets and data visualizations on budget spending and constituency features. It also includes data on land use, livestock farming, and infrastructure. It is really, really detailed. And while talking about this project, it's also a good opportunity to share something about the process at Code for Africa. As it's often the case, different teams work in tandem, focusing on different aspects of the project, and a shared collaborative mindset is necessary to avoid pitfall and getting stuck. The 4 key areas of the work are related to the analysis of data, designing the data, development of the charting tool, and producing the content. This process follows iterative steps. So while the designer is investigating visual routes to design the information, the data team is clustering and formatting all these datasets, extracting them from reports and PDFs. Meanwhile, the development team is setting up technical framework for the charting tool and waiting to get the first samples to start prototyping. We often converge on large Miro boards and where we would discuss almost every single aspect of the project and have a shared conversation on all these data sets, for example, asking how or why the data should take such and such form. To keep things very simple, we identified beforehand a limited but broad enough range of data visualization devices that we would use as blueprints or as templates. The tech team would then start to build those templates so that they can be populated later on by the data and the content team. As an example, this is a snapshot of one of our many digital wall conversations where we have group discussions on metrics, filters, and visualization techniques. Each dataset was assessed with 3 questions in mind: whether it was really useful to show in the first place, which indicators needed to be used, including filters, and which type of data vis device would make sense to use here. The final outcome is an explorable map and a dashboard that allows users to deep dive in a single area of the county, whether it's a small region or a larger county. And one of the coolest features of the platform is the possibility for users to pin and compare 2 counties or 2 municipalities side by side. Pinning features would turn the single column layout of the dashboard into a 2-column layout where 2 locations are compared side by side, allowing data visualization to resize accordingly. A map is also a useful way to navigate the experience so that you can quickly jump from the data visualization of 1 county to 2 counties. Our presentation ends here. Thank you very much for listening to us. As a final note, we wanted to remind you that Code for Africa offers free training both in person and online, with topics for entry level, from how to pick a chart to how to use data visualizations using software like Flourish or RowGraph. The courses already embrace a large audience of stakeholders and have more than 20,000 users in Africa. So please go to academy.africa. And if you want to stay in touch, please follow us on Twitter. Thank you very much.